So now let us look into the next problem statement. It is about getting top 3 crimes or crime types based on number of incidents in residence area. And if you actually get into the description, we have already seen as part of the previous success also, where we use the same data set. And similar to that, we have to read data from this location, public crime CSV. And then we have to split using regex because the data is not only delimited by comma, but also some of the fields in the dataset are enclosed by double quotes, and that field itself have commas. And if I just use comma as the delimiter, then our data can be incorrect. For that reason, as part of the problem statement, I have given the split logic also, which needs to be used, and we will split based on that so that we get the data in the correct fashion. And then we have to get top 3 crime types based on number of incidents in residence area using location description. So the values such as residence are provided in the column location description, which is one case number is second field, date is third field, block is fourth, IUCR is fifth, primary type is sixth, description is seventh, and location description is eighth. So we have to see whether the eighth field is equal to residence, and then we have to get the count within the dataset filtered by residence, and we have to get the count type, and we need to save the details about top 3 crime types with residence area, and the output needs to be in JSON format, and it need to have the crime type and the number of incidents for that. Okay, so that being said, now let us start working on this. So I'll be again using the gist to develop the code. So I'm actually logging into gist.github.com, and I will provide this URL as reference as part of the solution itself under the problem statement. So we have already seen how to read data from our earlier problem statements for this criminal or crime data. So I'm going to that just to pick up this Spark Shell command. So I want to use this command to launch this Spark Shell to process the data. And the reason why we have to do this, I have explained as part of the first exercise. Now I'm connecting to the lab. And pasting this Spark Shell command. And Spark Shell is launched. And if you have multiple statements or multiple problem statements on the same data set, we can safely use the existing code. So earlier also we processed this same data. So until here, it is same. So I'm copy pasting this to the new gist which I'm going to create. And also just to make it complete, let me copy the Spark Shell command also. Okay, and this is also solution using the Core Spark API. So I'm using the same, I'm specifying the same thing here. And then once you get crime data without header, which is nothing but a RDD, we need to apply the map function to extract the information we need. Map or filter functions to extract the data we need, and also to filter the data the way we want. And the logic to split is already provided. And most likely, when you actually face these kinds of questions in exam, they might give this logic to you. So you just need to know how to use it as part of your problem statement. If they don't give, typically all the data quality issues and all will be taken care by as part of the data sets itself. So they will not expect you to write this kind of complex logic in the exam, because it takes time to come up with this regular expression logic. So keep that in mind and don't get nervous by seeing this complex regular expression, and just use this if they provide as part of the exam. And it ends here. Okay, so I'm copying this, and then I'm saying crime data without header equal to crime data. Sorry, let me first filter out. Filter rec implies rec dot and give that split logic, and it gives an array, and we need to fetch the 8th field. We have already counted, and 8th field is the location description, and I can access using 7, and it will fill. Then I want to compare it to residence, and that is also given to us as part of the problem statement. So here I'm saying I'm only looking for residence data. If you are not sure about this, you can actually say you can actually copy this variable, and before actually using that, I need to run these 3 lines also. Paste, and then copy this variable, paste, dot, you can actually say map, record implies rec dot split. Let me take that logic from here. And then paste, and then dot take off 10 for each println, just to make sure that we are getting location descriptions without any issues, so that we can use as part of our filter logic. You can see here street residence, etc. And the problem statement clearly says they are only interested in residence. So as part of the certification, they give the exact information, and you can then compare like this as part of the filter logic, so that only residence data will be considered. Let us preview the data. I'm copying this and pasting it here. Dot take off 10 dot for each println, and you can see all the records have residence in them. And after filtering, we have to use map and get the crime type comma 1, so that we can actually perform the count for all the crime types within the residence location. So for that, what I can do, I can just say dot map. The output needs to be a tuple, and the tuple will have the crime type as the first field, and the second field has to be 1, so that we can add those values to get the count by crime type. As the data is already filtered by residence, and as our output doesn't require the location description, we can discard all the other information, including location description. Only thing which we need to fetch as part of the map is the crime type. And where is the crime type? If you go here, the crime type is, the primary type itself is crime type, and that is 3, 4, 5, 6th field. Okay, so hence I just have to say rec dot split of -1 and 4. Okay, let me see if it is 5th field. Sorry, 6th field. 1, case number is 2, date is 3, block is 4, IUCR is 5, primary type is 6, which is nothing but crime type. So this has to be 5 because the index starts with 0. This will give for each input record a tuple which is nothing but crime type or primary type, comma 1, and now I can actually use reduce by key and add these ones by saying total comma value implies total plus value. Okay, and then once you sort the data like this, you can actually say take order, because I need to get only top 3 records. I don't need everything. Okay, and if I run this, I'll get everything. As data is filtered quite a bit, here we can decide whether to use sort by key to sort the data and then take, or we can also use take order directly. It's your call. Either you can use sort by key or take order. If it is sort by key, you just have to say sort by key here, and then you can say take of 3, which will give the top 3 records, because data will be sorted, but by default data will be sorted in ascending order. To make it descending order, I can say false here, and then data will be sorted in descending order by a count by crime type, and then I can actually say take off 3 to get the first 3 records, and then to save it, it will actually give the array, and to save it again we have to use parallelize and convert into RDD, and then we have to save as text file to save the data in the text file format. So after this, what I have to do, I have to convert this into RDD, because take of 3 gives us the array, and writing array into the file system is not very straightforward. Hence we have to convert it into RDD, and then I can say save as text file. And before saving as text file, we need to understand the file format specified. Here the file format is JSON, so I cannot use save as text file to save it in the JSON format. We can use, but it is a bit tedious. Rather, what I will do is I will convert this into a data frame, and then I will try to save the data frame using SQL text. So for now, let me save this one as crime count for residence. Okay, and then this is the logic to get the first 3 records. Either you can use sort by key like of false and then take, or you can also use take ordered, and you can define the logic to get top 3 records. Okay, now let us first save this or paste this. Data is being processed. While it is being processed, let me copy this crime count for residence. Because of the regular expression logic, it will be a bit slower compared to direct splitting using simple expressions like comma. And now if you paste this one, dot collect dot for each println, you can see these are the top 3. Okay, there is some issue. I'm not sure whether they are top 3 or not. Sort by key of false should sort the data in descending order. Okay, before actually running this, let us run only this one. before converting that collection into array. And make sure this works fine. So it is okay. You can see here something is okay. I know what is the problem. So the problem is it is actually using the crime type as key to sort the data in descending order. That is incorrect. Here, before sorting, I have to swap the key and value. And the key has to be count and the value has to be crime type. So here, after reduce by key, I have to do map and then rec implies rec dot underscore 2 as key and rec dot underscore 1 as value, which is nothing but crime type. And after this, the data will be sorted in descending order by key, which is nothing but the crime count within residence. Now I can run this. While it is running, let me copy the variable name so that we can preview the data before coming up with the logic to save. Okay, now crime count for residence is nothing but RDD, and I can say paste dot collect dot for each println and hit enter. Now you can see battery is the top type of crime, and then other offense, and then theft. Okay, and now I have to save it to HDFS in the form of JSON in the path they have given. To convert it into HDFS, I can also say paste of that variable and then dot to df. Okay, and then with 2df, the field's name will be like this _1 _2, etc. If I want to give the names to save as JSON, if they specify that there should be names, then we have to use 2df crime type and then crime count. Okay, now you can actually say show to get the data. You can see the data. And with JSON, the order might not match much, but if the order is criteria, before actually converting to 2df, because it's an RDD, I can say map of rec implies rec dot underscore 2 comma rec dot underscore 1. If we have to get the crime type first and then the count, this is how you do. Previously, I gave the names incorrectly. Now it is correct. So the first field is crime type and the second field is crime count. And let me copy this one and hit enter. You can see data is as expected. Now I just have to save it. So the way I can save it is by saying the variable name dot map dot 2df, remove the show, and because it is a data frame, I can say write dot json and I can give the path, or I can also use save with path comma type, which is nothing but JSON, and this is the path we are supposed to save. Okay, and here I need to replace this, and that's it. So now the data is copied to HDFS, and one of the ways to validate the data is just by reading the data with sc.text file, because JSON is of text format. When it saves with structure, we can use sc.text file to see how the data is saved, and we can give the path, and the path I can copy from here. This is how you can actually validate the data once the data is copied to HDFS. And you can see crime type is battery, crime count is 244,395, and you can see the data is in descending order by field, and we got the data the way we want. Okay, and you can look at the problem statement. We want to save it as JSON. With JSON's delimiter does not apply, and there is no requirement to compress the data, and that's how we have created, and validation is also done. This is how you can come up with the solution for problem statements like this.